Okay, I'm going to do a line-by-line walkthrough on the EZL02 program. So what I've done is I've opened it here, and I'm in simulator mode. So let me go online with the simulator. Go to monitor mode so you can see it run. Okay, so the first line I have here is called call IO subroutine. So what I did was I created a subroutine called IO. And what it does is it maps the output coils to physical outputs. So we had talked about this in class, where in this controller you can sort of rename the physical outputs at the card level, but it seems like once you do that, you're sort of locked into that name. And I like flexibility. So what this does is very simple. This takes the output coils that you created, or that I created in the main logic, and just maps them to physical outputs. Okay, so that's all it does. Down here at the bottom, I have a flasher, they call it. All it does is turn on and off an output called flash 1. You can see it right here operating. So that'll blink one of the outputs when it's supposed to be on. Let's see what else is in this. Well, nothing. At the bottom, it's got a return, RET. So in this programming language, you have to have a return instruction at the bottom of your subroutine so it can come back to the main routine. So I'm going to close the subroutine. I don't need to see that. Line number 2 says that if input 1 is on, I should move data from the analog input card into a tag called convert tag. Okay. If input 1 is not on, I should move data from input 2 into the same tag name. So what I was trying to do here was make the system a little more flexible so that input 1 is the selector switch. And if I turn it on, I'll look at analog input 1. If I turn it off, I look at analog input 2. So I'm just trying to reuse the same logic for 2 different inputs. Normally I wouldn't do that. Normally I would have logic for each input, but just to have something to look at, right? Okay, so here's the scale linear instructions. Let me open that. Let me get out of monitor mode. Okay, so let's look at this for a moment. My input tag is called convert tag. You'll notice that it's an unsigned integer. It's a 16-bit value, which is fine. I think that's the default for this instruction. My input, my low end is 1. My high end is 4095. I get that from the data sheet of the analog input module. It tells me that 4 milliamps is represented by the number 1, and 20 milliamps is 4095. My output tag for this instruction is called channel 1 milliamp times 100. So what I'm going to do here is convert this raw number into another number that sort of looks like milliamps. So 400 is 4.00. 2000 will become 20.00. So it's milliamps times 100. Okay, so let's close that. Right below that, I use an instruction called data type conversion. So I would like my final value to be a decimal point value, like 4.00. So what I do is I convert this integer value into a floating point value. So I have to use this instruction to do that. Right here, I divide my floating point value by 100. And that goes into a tag called channel 1 milliamps. Okay, notice that pop-up window. It is a floating point value, so it is a regular number like we would see every day, 3.75. Okay, so what this does is it looks at my newly created channel 1 milliamp value and compares it to 8.00. If it's less than or equal to that, it turns on a coil called below 8. Okay, obviously, that's if I'm less than 8 milliamps, it will turn that on. This is greater than 8, less than or equal to 12, MA 8 to 12, okay. Greater than 12, less than or equal to 16, and greater than 16. So what else do I have? Nothing. Okay, so notice in the main logic, I do not need a return instruction because this is the main logic that executes continuously. I'm just looking for some things over here. Okay, so the goal of the activity was to modify this by adding another scale linear, which would take the probably, I'm just thinking which one I'd like to use here. It doesn't matter very much. I can use convert tag. I think I'll do that. I could use channel 1 milliamp times 100. I could use that. It really doesn't, I don't think it makes much difference. So what I'm going to do, I'm going to right click, insert new rung below. Okay, so I've got a blank workspace. I think I'm just going to scroll down and find that instruction, scale linear. I'm going to bring that over. Click, click. Okay. So my input tag, I'm going to use, I like the idea of using this one, but I want my final answer to be at 0 to 100. And I didn't specify if it was a floating point 0 to 100 or an integer 0 to 100. So let's keep it all floats, okay? So let's go with a milliamp float. My low end will be 0.0. Nope, 4.00. My high end will be 20.00. My output tag, this is supposed to be percentage, so MAPCT, okay? I press enter and I get this pop-up and I do want to float, so I'm going to say okay. My minimum output is 0.00. My maximum is 100.00. Okay. So that's it. Let's go back to monitor mode. And when I do that, I'm going to download to the simulator and run it. And let's see what it does. Now what I'll have to do is kind of see a problem already. See the numbers are too big. Let's go back to this edit mode. Let's see what went wrong here. Channel 1 milliamp float. Oh, I picked the wrong tag. I really wanted channel 1 milliamps. Okay, no problem. Channel 1 MA. And let's try that again. Okay, so 4 gives me a 0. My problem is I need a way to force these numbers so I can test it. Okay, and I don't know if I can't force them from here. I think what I'm going to do is I'm going to go to my local tags. Let's go to my local tags here. Okay, I'm going to try and force a number into that, like 500. You know, Let's try the other one since it's working off of the other one. Okay, zero that out. What I'm doing is I'm double clicking on that and I'm just plugging a number into it. So since this is on right now, input 1 is off. So I'm using input register 2. Okay, so let's go back and do a better job. Let's put a 1 in there. A 1 represents 4 milliamps, a percentage of 0. Let's try 2048 because that's halfway. And I have 50%. Okay, let's go to 4095. I'm at 100%. Let's try 4090. Okay, looks good. Okay, it looks like it's calculating the percentage. So let's see, half 2048, 1024 should be about 25%. Okay, half of that is 512. That should be 12.5%. Half of that. So it looks good to me. Let's go with a higher number than I can generate, 5,000. Well, now my card will never go above 4095, but you know, this brings up a good talking point, and that is, what if the raw number coming in goes above 4095? Well, it looks like it drives the output over 100. So, you know, I should probably check the value coming in, and if it's too high, just clamp it. So let's work that in as well as kind of a side note. I think I'll do it here. Let me go back to monitor mode, or I'm sorry, edit mode. Let's go right here, put a new line above that. What I want to do, let me look around for a second here. I want to say that if the convert tag is greater than 4095, if that's true, then I want to move 4095 into convert tag. Okay. So what this does is it's going to force that number back to 4095, and that should fix my problem down here. So let's try that. Let's do a monitor. Let's look at my local tags. Let's force. Let's go back to 0 here. Okay, and then let's just jump right up to 4090. And then let's jump up to 5,000. Okay, see how it locks it down at 4095. So if my convert tag tries to go over, it will hold it at 4095. So let's go back to 0 here. Let's just try 5,000. That's interesting. Oh, well, sorry. It picked up that 0 there. So I guess I can't force a number higher than 4095 because it's always going to go back to the input register value. So this would work. Yeah, this will work just fine. So sometimes what you need to do is find out what could go wrong in your program, and then find ways to protect the program from that. Okay, by checking the range of input values. Sometimes you can limit the range. If you've got some kind of an HMI touchscreen interface, you can probably set the min-max values on the numbers coming into it. But anyway, just long story short, the answer to activity 2 is this block right here. Okay, the 4 to 20, 0 to 100. This greater than was an afterthought, but it's a good afterthought. You know, we don't want our outputs to go above where they should be. it causes trouble, right? Okay, so that's the end of this video. Hopefully it helps a little bit. And see if you can modify your program and get it to run. You can try it on your hardware because you have the actual hardware in front of you. Okay.